Now that specific energy also can be obtained, or that specific energy can also be obtained, means by first of all drawing the that potential energy curve. First of all draw this potential energy curve, then after that draw this curve which having this equation, that's q square 2g into h square, curve of kinetic energy, and then combine these two curve, we'll get specific energy, right? So first of all means draw the potential energy curve. So what is that curve? It is nothing but which will be a straight line passing through the origin, making an angle of 45 degree with the x-axis. Now if you draw a curve, now just see this figure, right? So this figure is nothing but that specific energy which is obtained by drawing that two curves, potential energy curve and kinetic energy curve. Now just see here, right? So this curve, this is nothing but this is the potential energy curve, right? Now means this EP is directly proportional to h, means h, so this potential energy will vary linearly, so the curve is linear like this, right? Because it is directly proportional to, right? So we'll get that this curve is nothing but a straight line, a linear variation. So this line makes an angle of 45 degree with the x-axis. So we'll get this curve, potential energy curve, right? After drawing this potential energy curve, right, now draw that kinetic energy curve, right? Now what is kinetic energy curve? We know this equation, kinetic energy is equal to q square into 2g into h square, right? So this kinetic energy curve which will be the parabola as shown in figure. Now if you observe this again, this figure now, and if you draw that kinetic energy curve, now just see, so this kinetic energy curve, right? So this is your kinetic energy curve for right? So for different values of h, if you find this kinetic energy, so you will get the curve like this. This is nothing but this is a parabola, right? So this is a kinetic energy curve. Okay, now if you combine these two curve, right, in order to find that specific energy curve, as we know specific energy is nothing but it is a potential energy plus kinetic energy, right? So just we have plotted that potential energy curve, this first one, and then we have plotted this kinetic energy curve, this one, that parabola, and if you combine these two curves, so we will get this curve, right? That is nothing but your specific energy, or this is a specific energy curve. So equation of is nothing but that h is equal to q square 2g into h square, right? So this is your specific energy curve. Okay, so we can obtain this specific energy curve in this manner also, right? So there are two methods to find that specific to draw that specific energy curve, right? Now in this, if you see some terminology there, so hc is there, what h1 is there, and h2 is there. Now what is hc? Hc is nothing but it is a critical height. So now if you observe, it is the height of this point c from this x-axis, means what? Now if you observe this point c, right, this is specific, your specific energy curve. So at this point c, that specific energy is minimum, right? It is how much? It is a minimum. This is nothing but this your minimum specific energy. So corresponding height of depth of the flow is nothing but your critical depth or critical height, which is denoted by hc, right? And this h1 and h2 is greater than hc and h1 is less than hc. Okay, right? Now these are some terminology. We will study about this later on. What is this, all these terms, right? Now if you observe this specific energy curve, right, so this specific energy curve entails the following information. So this specific energy curve or plot entails the following information or following properties, right? Now first one is what? First information is the curve for potential energy, that EP is equal to y. This is the equation of that potential energy. That is nothing but y is nothing but h, or that is the depth of the flow. It's a straight line. So this is your what? This is the first property of this curve. That is nothing but that potential energy is a straight line which is passing through the this 45, which is passing through the origin, and which makes an angle of what? 45 with this x axis or with the y axis, right? So this is your first property of this curve, specific energy curve, right? So the next is what? The curve for kinetic energy. Now the curve for kinetic energy is a parabola. Now the curve of that kinetic energy is nothing but it is a parabola. This is the curve of kinetic energy, right? And Then after that, after plotting this potential energy curve and kinetic energy curve, this potential energy curve and kinetic energy curve, and if you combine these two curve, we will get what? Specific energy curve. So we will get, after combination, or we will get this specific energy curve, right? Now next, third property, that is nothing but the specific energy is asymptotic to the horizontal axis for a small values of h and asymptotic to the 45-degree lines for high values of h. Means what? Now if you observe the specific energy curve, right? So this specific energy curve, right, and this what? Horizontal axis. Now if you see this horizontal axis, so these two lines, now if you observe, this is a horizontal axis x, and this is your specific energy line. So these two lines never intersect, right, but they are parallel, right? So that property is called as asymptotic, right? So that is nothing but asymptotic, right? So means, so this specific energy is asymptotic to the horizontal, that x-axis, and similar to that it is asymptotic to the this 45-degree lines or that potential energy curve. Means these two lines never intersect, right? So this but they are parallel, right? So they are called as what? Asymptotic to each other, right? So therefore this specific energy is asymptotic to the horizontal axis for small values of h. Means he, so at this, when that specific energy curve is asymptotic at the x-axis, the h value, that is nothing but depth of the flow, is very small, and here the depth of the flow is what? High. Means if the specific energy or that specific energy is asymptotic to the that 45-degree lines or the potential energy line, at that time the depth of the flow is more, or it is having the high values, right? So then after that, right, now at certain depth, next property is after that certain depth hc, this hc is called as what? Critical depth. The specific energy is minimum, and the corresponding value is called as critical velocity, is called as critical velocity. Now just see here, what is this point? What is the meaning of this point? If you observe this point c, right, so at this point p, how much is the specific energy? The specific energy is minimum, right? So corresponding depth of the flow where the specific energy is minimum, it is called as critical height or critical depth of the flow, that is hc, right? hc is nothing but it is the critical height, right, or critical depth, right? So and the corresponding velocity to this depth of, or corresponding velocity, and with respect to this critical depth, right, that velocity is called as what? Critical velocity, right? So understood, right? So hc is nothing but your critical depth where specific energy is minimum, and corresponding velocity is called as corresponding velocity corresponding to this hc is called as critical velocity. So we'll study about this hc in vc in next lecture, right? Then after that, now there are two depths, h1 and h2. h1 is greater than hc and h2 is greater than hc, are called as alternate depths or conjugate depths. Now just see this figure of that specific energy curve. Now here h1 and h2, there are two depths. Now h1 is less than hc and h2 is greater than hc. So these depths are called as alternate depths or conjugate depths. One is greater than hc and one is less than hc. So these are the alternate depths, right? So this is about the that properties or the information about the, right, specific energy curve, and this is about the specific energy curve. Thank you.